Hey guys, in today's video we're going to look at the rules of differentiation, more specifically looking at the derivative of our functions when in the form x to the power of n. So in the previous video we talked about using differentiation of first principles to find our derivative function, but as you can see this is a lengthy and time-consuming process. And there is a much quicker way of finding our derivative functions, and there are specific patterns for each type of function. So today we're going to talk about the derivative of x to the power of n, where n is a non-zero integer. So we're talking about polynomials in this case. If we have f of x equals x to the power of n, then we can use this formula to find our gradient function. So our gradient function f dash of x is equal to take whatever the value of n is and imagine that coming out to the front of the function. So we have n coming out to the front of the function, and then we multiply by our polynomial, so x to the power of, instead of the power being n, now our power goes down by 1. So it becomes x times x to the power of n minus 1. So if you remember this formula here, that every time you see the derivative for a polynomial like the one down here, all you have to do is use this formula rather than going through the entire differentiation by first principles to find the gradient function. So let's have a go at two pretty straightforward questions here just to help consolidate the concept. So question 2, find the derivative for y equals 3 times x to the power of 5 plus x cubed. So we have y equals this function here, and dy dx, so this is our gradient function notation. Remember, we use this one every time we have y as our function. So this is equal to, first thing we do is bring the 5 out to the front. So imagine this 5 coming out to the front. So then we have to multiply by this 3, and this gives us 3 times, put this in red, 3 times 5, multiplied by our x here, and x is now raised to the power of 5 minus 1. So our power goes down by 1, like this. And we do the same with this term as well. So plus, the same thing happens, the 3 comes out to the front, so now we have 3 multiplied by x to the power of 3, once again goes down by 1, so it's 3 minus 1. And then we just simplify everything. Dy dx is equal to 3 times 5 gives us 15 times x to the power of 4 plus 3x squared. So you can see how this formula here is a lot quicker and a lot more efficient than going through this entire process to find our gradient function. Let's do the same thing over here. Now we have a negative number. So once again, y equals x cubed minus 6x to the power of negative 1. So the question wants us to find the gradient of the curve when x equals 4. The first thing we need to do is find the gradient function. So dy dx is equal to, the 3 comes to the front, so we have 3 multiplied by x to the power of 3. Once again, the power goes down by 1, so it's 3 minus 1. Minus, now even though we have a negative power here, we treat it just the same as these positive integers as well. So the negative 1 comes out to the front, so this entire number comes out to the front. So what we have is 6 multiplied by negative 1. and then multiplied by x to the power of -1, and we still subtract 1 from the power, so it's -1 minus 1. Okay. So we just treat our negative integers in exactly the same way as we do with our positive ones. And then let's simplify everything. So dy dx is equal to 3x squared plus, because now we have -1 and -1, so this becomes 6x to the power of -1 minus 1, which is -2. So this is the equation of our gradient function. Now we want to find the gradient of the curve when x equals 4. So we simply substitute x equals 4. So dy dx when x equals 4 is now equal to 3 multiplied by 4 squared plus 6 multiplied by 4 to the power of -2. Simplify everything out. 4 squared is 16. 16 times 3 is 48 plus 6 multiplied by 4 to the power of -2. 4 to the power of -2 is the same as 1 over 4 squared. So we can write it in this way. And then that simplifies to 48 plus 6 over 16, which is 48 plus, that simplifies to 3 over 8. And 48 plus 3 over 8 gives us 387 over 8. So to answer the question, the gradient of the curve when x equals 4 is this number over here. So the gradient when x equals 4 is 387 over 8. So this is how we go about differentiation for our functions of the form x to the power of n.